Alyssa, do you know what AC stands for?
Air conditioner?
Are you seriously a second-year electrical engineer? Don't worry, guys, you will find out soon.
Welcome. Today we are going to talk about the basic characteristics and features of an AC sine wave. Oh, sorry, of an alternating current sine wave. When talking about alternating waveforms, the most common waveforms are sinusoidal, square, triangular, and complex waves. For this video, we will speak to the sine wave, which is the most familiar AC waveform. To understand sine wave better, let's look at an example of a sinusoidal voltage wave. Here you can see a sine wave plotted on an axis with voltage being on the y-axis and time being on the x-axis. First of all, we have the wavelength. That is the distance between two consecutive peaks or troughs. Next up is the time period, which is the time it takes to complete one cycle. Equilibrium is the point where voltage is equal to zero. Peak value is the max instantaneous value of a function as measured from 0-volt level, which is the same as amplitude. Peak to peak value is the full voltage between positive and negative peaks of the waveform. That is the sum of the magnitude of the positive and negative peaks. Lastly, the RMS or effective value of a sinusoidal waveform is the equivalent steady DC value, which gives the same heating effects as DC, which can also be written as Vp upon under root 2. After looking at the important parameters of a sine wave, let's look at the mathematical representation of a sine wave. V bracket T is the voltage level at any point in time. Amplitude is denoted by Vp. W is the angular velocity, which can also be written as 2 pi f, where f is the frequency of the wave. T is time as a variable. The plus and minus sign indicates that if the wave is lagging or leading. Lastly, phi is the phase shift in degrees, which shifts the wave on the vertical axis. We can also add plus d in the equation, that is the DC offset, which is the horizontal shift of the sine wave. To understand the phase shift better, let's look at these two examples. In the first one, we can see that both waves cut the x-axis at the same time. Hence, there is no phase difference between the two waves. In the second, in which sine and cos waves are on the same axis, we can see that the cos wave is leading the sine wave by 90 degrees. This 90 degrees is referred to as the phase angle or phase difference between the two waves. That brings us to the end of the video. I hope you all have an idea of what AC sine wave is by now.